Okay, there we go. Hello. So welcome. We've got a few folks here in the room with me at Olin Library. Welcome. And we also have several folks that have joined us on Zoom. So welcome to you all. Thank you so much for coming to this workshop this afternoon. My name is Molly Webb. I am a geospatial programs manager and GIS developer on the data services team here at Olin Library. And today we're going to be talking about cleaning our data using Python. But what options do we have for data cleaning? Well, we have a lot, and which one you use kind of depends on your comfort level and the longevity of your work. So today, obviously, we're going to be talking about Python, which is a really versatile scripting language for doing complex processing tasks and automation. You may already be familiar with the product Excel, which is a licensed product, but good for just opening up data, taking a look at it, and doing quick basic tasks. You can always use text editors if it's something super simple that you need to adjust. And then there's a lot of other applications that require separate downloads onto your machine. So OpenRefine is an open source web-based application that is really good for combining files and finding clusters of values and things like that. RStudio can do pretty much anything that Python can do, really. And it, like Python, is also a free open source and cross-platform scripting language. Finally, we've got a couple of licensed products, Tableau Prep, Stata, and SAS. They each have their own strengths, and Tableau Prep is more of like a GUI-based data cleaning application, and Stata and SAS are going to be your scripting-based applications. So lots of options for data cleaning tools, but today, obviously, we're going to talk about Python. And of course, I do need to just make a comment about AI here. We're going to see AI even baked into the code that we're writing today. So my personal note on AI is absolutely use it. In fact, please do. As a programmer, I use it almost daily just to make my life easier with writing code. However, big but here, you are still responsible for your work. We're all responsible for our outputs. We're responsible for making sure that they're correct and that our Python code is running properly. So it does help to have an idea of what the code is doing, where your files are going, the basic knowledge of syntax, and so on and so forth. It's still a really useful tool to actually learn how to write Python code, even though AI can help us out a lot with it. So we're going to talk about Python on our computer for a few minutes before we actually get into the code. So when you install Python on your computer, Python basically puts three chunks of things onto your computer when you download Python. These are the building blocks of the Python language. So first on the left, we have classes, and classes are the basic objects that we're going to be working with. So imagine classes as like pieces of information that we're going to be working with within our code. In the middle here, we have functions. So these are blocks of code that actually perform a specific task. And then we have modules which extend the functionality of Python by including additional functions for specific tasks. So within classes, each class has properties, which is information about the class, and then methods, which are the behaviors of the class. So methods are basically like the functions associated with classes. Functions, specific to them, they have parameters. So those are the pieces of information that you pass into the function that make your function do specific work to your specific data. And then modules have both of classes and functions, which, of course, properties and methods go along with the module classes, and parameters also go along with the function classes. Now, this is a really high level overview. So if you don't quite understand all of these things, no big deal, but these are the kind of basic building blocks of Python when you install it on your machine. All right, so imagine we take our classes, functions, and modules, and we push those off to the side. On the left-hand side of the screen, that is what we call base Python. So as soon as you go out to python.org or whatever, however you decide to get your
Oh,
Python install,
okay. Yeah,
and you
yeah.
install it on your computer, it's
Mhm.
going to come with
Yes,
everything.
we just
Okay, so if you install base Python, you've got your classes, functions, and modules. Then you can go out to the internet and you can install additional modules or also called libraries. We're going to call those third-party libraries, and those are even a separate installation onto your Python instance. And again, those modules are going to come along with classes, functions, and modules along with it. Okay. When you install Python on your computer, you can actually have multiple copies of Python on your machine. So imagine we've got my computer here. We could have an older version of Python, so say Python version 2, which has its own libraries associated with it. And then the more recent version of Python is Python.3. And you can even have multiple instances of Python.3 on your machine, each with their own libraries. So when you're working with Python on your own machine, it's important that you know which Python instance your code is pointing to, because that's going to make it clear what libraries Python has available to actually run against. So we're going to dig into syntax a lot more when we actually start running the code, but just to go through a quick primer on what the syntax actually looks like. So when we have a class and we need to get a property from that class, the syntax is the name of the class dot property. So for example, if we have an object that is a data frame, so basically an in-memory table of information, and we want to know how many rows and columns are in that data frame, we can call dataframe.shape, and that's going to return the number of rows. That's the first number in that in between the parentheses, and then the number of columns is going to be the second number. So that is an example of how you can get information about a class by calling the property. So in this case, the shape property of the data frame. When we're talking about methods associated with the class, the syntax is usually the name of the class, the name of the method, and then open and close parens with 0 or more parameters here. So for example, say we have a string, just a piece of text within Python. There is a method associated with the strings in Python that is the replace method. So the syntax here would be the name of the string dot replace, open paren, and then two parameters here. So we've got two parameters separated by a comma. The first parameter is going to be the string that you want to replace. And then the second parameter is going to be the string that you want to replace the string with. So for example, say we have a string that says hello world exclamation point. And we run the replace method and we say, okay, Python, find all of the instances of world, this string here, and replace them with WashU. So then if we print out my string again, the string is going to say hello WashU instead of hello world, because it has replaced the instance of world with WashU. And then finally, when we're talking about the libraries themselves, so those larger modules here, and we want to call a function, the syntax is very similar. Only this time we're going to say the name of the library dot the name of the function, and then in open close parens, 0 or more parameters. So for example, in the pandas library, which is what we're going to be working with today, pandas has a read function. And so we can call pandas.read and then insert the name of the file. And that is going to then read in data from a file. That's behavior that that function is going to do. It's going to read in the information from a CSV or whatever file you happen to have. So a couple of just general tips on writing Python code. Um, First of all, I recommend setting all of your file name variables and workspace variables at the beginning of the script. And that is so you don't, if you say you are working on one machine and then you move machines and now your files are located at a different path, you don't have to go through your entire code and hunt and find the instances of the workspaces that you have to change. You can just change those all at the beginning. And then a few things that I recommend paying attention to. The first one is data types. We're going to be looking at that a lot today. The locations of files and other data sources, and then also the locations of any outputs. So if you are creating any files, where are those files going to be saved? These are the biggest issues that I see students and researchers coming to me for help with. And so I put them right here at the beginning so we can just say, okay, we're going to pay attention to all these things. Okay, and finally, before we get into the code, I want to just introduce the Pandas library. So again, this is a separate library that you have to install in addition to installing Python. It's a very popular library for data cleaning and data science. And the basis of the Python library is the concept of the data frame. So when we're talking about a data frame, it's just a table with information. And we've got just a series of rows and columns here. In the first column, that is the index column. So that is basically specifying which row we're talking about. And then subsequently, we have several columns that in the Pandas language are referred to as series. So city, state, zip, income, those are all series within the Python library. So the object or the class that we're talking about is series, and these are within the data frame class. All right, so with that in mind, now we're going to switch over to actually looking at the code and doing some things in Python. So let's get started here. If I could ask you to refer to the Google Drive link that I sent in my email. And just for the participants on Zoom, I'm going to paste that link one more time if you need that. So you can just get right there. And everybody here in the room, do you have this link? Okay. So let's take a look at what is actually in this Google Drive folder. Okay, so we've got the presentation that I'm going through here, as well as a PDF copy. We've got this file IPYNB, that is a Python notebook file. So essentially, this is what's going to be running our Python code. And then we also have an additional folder called workshop data. So right now, what I'd like you to do is right click on that folder and click download and go ahead and get that workshop data folder downloading. It's not super big, but if you all try to download it at once, it might take a couple seconds here. And once you have that folder downloaded, it's going to be a zip file that probably looks something like this. So depending on what kind of machine you're using, Windows or Mac, I want you to unzip this file. So I'm here on a Windows machine. I'm going to right click and go to extract all, and I'm going to choose that I want to extract this folder to the desktop here, or you can put it wherever you want, just as long as you remember where you put it. And then if you're on a Mac, you're going to right click and you're going to use that archive utility, and that is going to unzip that file for you. Once you have that folder unzipped, you're going to see that there's several CSV files in the folder. And chances are we're probably going to only get around to using the file sample survey data and then the STL city population 65 plus today. But depending on how far we get, slash, if you're really enthusiastic and want to work through some of the bonus content that I've provided, we've got these additional files here too. All right. So next, let's go back to the Google Drive folder and let's double click on the .ipymb file. And so this is going to open up a Python notebook in a platform called Google Colab. This is a web-based way to run Python code. It's free. So if you have a Google account, you have access to these Google Colab notebooks. And Jupyter notebooks or Google Colab notebooks, it's all kind of the same thing. You'll hear that those terms used kind of interchangeably. Um, they're made up of cells where you can put text and then cells where you can put code. And the cells where you have code in them, you can actually run those in a Python environment. And so we'll get more into that here. Just a little kind of tour of our notebook. And I'm going to make this as large as I can here. So on the left-hand side, we've got some icons. And if you click on the top icon, we've got the table of contents. So if you want to kind of skip around into the different headings of the workshop, feel free to use these kind of nav jump links to do that. There are ways that you can do like find and replace on your code, and you can insert code snippets. And then also if you have like password secrets, you can access them with this icon. What I'd like you to do now is click on the bottom icon, the files icon. And once your files area looks like this, and you see this upload files icon here in the upper left, you're going to click that upload files and go ahead and navigate to where you unzipped your workshop data folder because you remembered where you unzipped it, right? So it'll be really easy to get to it now. And then go ahead and upload all of these files. So I'm just going to click on the top file name. I'm going to hold my shift key and click on the bottom file name to select all of the files. And then I'm going to click open and they're going to upload to my Python environment. So now my Google Colab notebook can access them. I do see this warning here that's just telling me, hey, when you close this Google Colab notebook, all your files are going to go away. So make sure you have them saved somewhere where you can take them with you when you're done. So I'll just hit OK on that. So now I can see all of these files are available in my file area. And this is great because now my Python code can access these files. So we're going to be accessing code from a file like this, and then we're also going to be accessing code from a file saved on Google Drive. So we're going to do both options here. There's a lot of different ways that you can bring your data into your notebook or into your Python script, and these are just two of those. Now that we have my files uploaded to the environment, I'm going to close that sidebar there and give me the maximum real estate for my Python code window. Okay, so like I said, the Python notebook, also referred to as a Jupyter notebook, we can have text cells and we can have code cells. So these first couple of cells, if I just click into each one of them, we can see that these are our text cells. So this is where I can give you information on what is happening within the code. I can give you links. It's where I can set my anchors for the navigation and so on and so forth. This cell here is a text, or excuse me, is a code cell. And you can see it looks a lot different. Well, not a lot, but it looks slightly different. First of all, we've got this little play button here on the left-hand side. And also the text looks more like code, kind of system type text. All right, so we can tell that that is a code cell. So our very first cell, what our first cell is going to do is it's going to import the libraries that we're going to use for our script using the syntax import space and then whatever the name of the library is. Now, some of these libraries are the built-in modules that come along with Python. That would be our OS library and our sys library. Those both come along when you install Python. You get those libraries or modules. You can use those words interchangeably. And then we've got two libraries here that if you were doing this on your computer itself, then you would need to install these separately. So that's the pandas library and the numpy library. So the syntax here is saying, okay, go ahead and import the pandas library. And then throughout the rest of my script, I'm going to be referring to the Python or to the pandas library as PD, just to make it a little bit easier, a little bit less typing. So pandas is going to be PD and numpy is going to be NP. All right. Now, since this is all a web-based Python environment, we don't need to do any installation here. The Google Colab folks already have these libraries installed within this Python environment. So all we need to do is just use this import statement to actually import them into our script and say, hey, Python, we're going to be using these libraries at certain times. So let's just get everything kind of loaded up and ready to go. To run the cells, we could just click the play button here and it's going to kind of work for a few seconds. And then what we want to see here are these green check marks. So that says, yes, this code cell ran successfully and you're ready to move on to the next one. The other thing we could do to run the cells is with your cursor in the cell, you could hit Control Enter and that will also run that cell. All right. So this notebook is something that I have pre-written already, and we're going to be kind of walking through the syntax of each cell. So feel free to go ahead and just run these cells as I'm running them. If you move ahead a little bit, that's fine. Because everything is just written out here with instructions and all of that. So sometimes a question that I get in these workshops is, how do I know what version of Python this notebook is running? Because there's no real, like, I didn't install this myself. So, you know, I need to kind of make sure that I'm familiar with what version it is. Remember, we talked about Python 2 versus Python 3 and so on and so forth. So I can run this syntax print, which just, as you might suspect, just prints out information. And then I can use the property within the sys module to get the version of Python here. So if I click the play button here, it runs and it prints out that this version of Python is 3.12.11 and that it was released in June. So it's a fairly new version of Python. Chances are there's going to be another one coming out pretty soon. So by the time I do this workshop next semester, we'll probably be looking at a different value here. Okay, next up, we're going to set all of our local file names as variables. So this is what I was talking about in terms of setting all of your workspace variables at the beginning of the script so you don't have to go hunting for them later on. And we're going to do a couple things here. We've got some variables, data file name 1, data file name 2, and data file name 3. So the first data file name is the name of the sample survey data CSV that we're going to be working with. And if I just double check on my file window here, I can see that that matches the name of one of the files that we uploaded. Okay, so basically just getting the name of the file in there so Python knows what file to bring in. For data file name 2, technically, the second file we're going to be working with is this city population CSV. However, I wanted to make sure that I demonstrated how you can get data from a different source, specifically Google Drive, a shared folder in Google Drive. And so instead of using the name of the file here, we're going to be using the share link for this particular file. So just to get that link, all I did was I go to my workshop folder and I go into the workshop data and I just pull this file link here. Go. I just pull this file link here from the share copy link. That's all I did there. Okay, so that share link is what we're seeing here for data file name 2. Okay, so we had a question in the room. What does this R mean here before my text string? And so what the R means is it's telling Python that this is a raw string. So it's saying, hey, Python, I want you to read this string exactly as I have specified for you here in the text. And the reason why we have to do that is because Python has several what they call reserved or escape characters. And these forward slashes here just happen to be one of those reserved characters. So if I were to pass this string to Python without putting this R in front of it to indicate that it's a raw string, Python might interpret this string as maybe HTTPS colon only one forward slash, or it may remove the forward slashes altogether from the URL. And so putting the R in front of it is just a way to tell Python, I need you to look at this string exactly how I'm giving it to you. I don't want you to remove any characters or consider any of them as reserved or escape characters. Thank you so much for your question. I'm going to make sure I include that next time I do this. All right. Let's run this cell that essentially puts our file names in there as variables. Okay. Now that we have some variables set, I want to show you another kind of cool feature of the Google Colab Notebook, and that is this variables section here. Okay, and I'll get to that question in the chat just 1 second. So when I click on variables down in the lower left-hand side of the screen, it brings up this variables inspector that says, okay, you now have 3 variables entered into your script. Here is the data type of them and a little bit more information, like one's 22 characters and here's the value and so on and so forth. So for those of you that are used to using R and RStudio, this is very similar to the environment variables window that you see in the upper right-hand corner of that application. It just gives you an idea of what variables are being stored for this script. And I'm going to close that. And let's see what our chat says. Is there a way to run the code line by line within the cell? I believe the answer to that is no. I think you can only run the whole cell. So if you just want to run the code line by line, I would put each line that you want to run in a separate cell. If anybody knows different, please do let me know. Thank you for that question. So now we're actually going to bring in some of this data and we'll be able to take a look at it. So the first thing we're going to do is we're going to use read CSV, which is a function of the pandas library. We kind of looked at something similar when we were going through the syntax. So this particular function is read CSV. So if we look at this syntax, we're creating a new variable called data. And then the value of our variable data is going to be what we get from reading in this CSV. So we're going to call the pandas library, so .pd, .read underscore CSV, and then we've got one parameter here, which is the name of the data file. All right, let's run our play button, and we're not seeing any output here, but our cell ran successfully. So let's see how we can interrogate this data a little bit more. All right, first we're going to use our data.shape. So we looked at this in the presentation also. The output is going to be a tuple, so that's 2 pieces of information within parentheses that's going to give us the number of rows and columns. All right, so data.shape to get that shape property. We can see that this particular table has 1,068 rows and 5 columns. Say we want to take a look at what our data table actually looks like. So we can call the head function. No, actually, sorry, this is going to be the head module. So the head module is associated with the data frame. Or sorry, head method. I always get those confused. So this is going to be the head method of the data frame. And what this does is this is going to print out or display the first 5 rows of the data set. So this is just a really good way just to make sure your data set is the data that you think you're bringing in. And we can always adjust if we wanted to see like the first 20 or the first 10 or whatever, we could just drop those in as a parameter of this method and it would give us more. So let's take a look and see what that looks like. So I ran that and it displays the first 5 records of our data frame as well as the index column, the index for each row, and then also each column, case number, city, state, income, zip income. All right, so this looks about like what I expect. And so I know from looking at the shape, I know that I have a little over 1,000 records here that hopefully look very similar to this. This is also another good point where if you don't want to have your output displayed like this, say you want to keep your screen a little bit cleaner, you can always right click into the cell and you can say clear output, and that will clear that output. So you don't have to have it, expanded if you don't want to. Next up, we're going to have the count. So let's run this and see what happens. So again, this is the count method. We know it's a method because of our parentheses here. And so what this does is it goes through each of our columns and it gives us the number of non-null rows for each column. So we can see that in most of our columns, all of the records have values, except for the income column. It looks like we do have some nulls in the income column. And so this is really important because if you have a data set with like millions and millions of records, you don't want to write code that assumes all the values are filled in and then have it get to record 590,064 and then have your code fail. So it's good that that we can kind of quickly here see any null values within each column. All right, and so then we'll take a look at the describe method and a couple of different iterations of this. So if we say data.describe, this gives us basically a little summary. By default, it is going to give us only the numeric data types. So if I go back and open up my head again, we've got case number that it thinks is numeric, and we also have zip code, which Python thinks is numeric. Now, actually, neither of those are numeric, so we're going to have to work on that a little bit. But if they were, here are some summary values here. So the min, the max, the different quartiles, the mean, so on and so forth. Say I want it to give me this kind of summary for all of the records, not just the columns that it thinks are numeric. I can say data.describe, and then within my parentheses, I can pass one parameter, and that is the include parameter. So I say, okay, data.describe, open parens, include equals all in quotes. And this is going to just give me this output for all of the columns. Okay. So for our non-numeric columns, obviously it can't give us the mean and the standard deviation, but it can tell us useful information like how many unique values we have in all those columns, and maybe the value that appears the most. So again, these are just some quick, easy ways that you can interrogate your data, and you don't have to like load the whole thing in there, especially if you're dealing with a particularly large data set. And then if you want to say, okay, I only want you to include specific data types in the summary, we're again going to use the data.describe and then the include parameter. But this time what we're going to do is we're going to pass in a list of different object types. So I know this is a list because it's in square brackets. We use square brackets a lot in Python, and sometimes they're doing different things. But in this case, this means a list. And in this list, we actually have one element in this list, and that is the object data type. So this is saying, okay, give me a summary of all of the columns where Python, you think that it's the object data type. And the object data type is basically just like a mixed data type. It means it could have numbers or it could have text. All right, so for this, it says, okay, I think your object data types are city, state, and income, and then here's information about those. Yeah. Yeah, that's a good question. So just to repeat the question in the room here, we had a question, why is Python recognizing something like zip code as a numeric data type, and it's not recognizing income as a numeric data type? Okay. So when you read in the file, Python is going to really quickly just look through all the values and it's going to make, I mean, I say guess like I'm personifying Python, but Python is going to say, okay, here's the different values that are coming in this column. And so here's what I think this data type is. Now, zip codes are not numeric. They're actually categorical. They're basically just like a label for a particular area. The only thing is we use numbers to show them. And so Python looked through this column and it said, oh, I think all these are numbers. So this must be a numeric one. I'm just going to go ahead and make it numeric for you. Okay. Now, we'll see a little bit later that in the income column, we actually had an erroneous text value in there, as well as some nulls. And so Python went through and it's like, oh, well, there's a text value in there. So I'm going to assume that this is a mixed case and I'm going to make it an object data type. Now, I specifically planted that text value in there because we're going to mitigate it later on. But that's why it did that. Like Python's just going through and is saying, I think I see all numeric values here, so you're a number. But that's a great segue because that's one of the things that we need to fix. All right. So imagine that I have this, kind of big data set and I want to use it for some analysis for my project. And there's a couple of things that I need to do here. First of all, as we've already established, the zip codes came in as numbers. I need those to be strings. Having a numeric zip code does not really help me much. And in fact, it can actually hurt us because if you're familiar with zip codes, say on the East Coast of the United States, those zip codes start with 0. And so if Python recognizes that data type as numeric, it's going to strip out those leading zeros, which can lead to mistakes when we try to access certain zip codes that might start with 0. So that's the first thing we need to do. We need to make sure that all of our zip codes are recognized as strings. Secondly, we need to make sure that all of our income values are numeric, because say we want to do some numeric analysis on them. So we need to make sure that we're having all valid numeric values there. Third, we want to ensure that our city names are valid and consistent, and a little bit more about that later. And then finally, we have a second table. And so we want to ensure that we can take this first table and join it to a second table using zip code to match those records. All right, so we've got kind of 4 objectives here for our project that we need to do before we can move on with our analysis. Okay, so let's talk a little bit more about data types here. So the first thing I'm going to do, I'm just going to confirm again what data types Python thinks these columns are. So to do that, I'm going to call the dtypes property of the data frame. So again, my variable data represents a data frame class, and the data frame class has a property called dtypes, and that tells us the data types that Python thinks it's recognizing here. So I'm going to run this, and it's going to give me a list of all the columns, and it's going to say, okay, case number, I think that's an integer. Int64 essentially means 64-bit integer. For city, state, and income, I think that those are objects, so essentially a mixed case. And then zip code, I also think that that's an integer, so whole number. All right. Pretty much all of these are wrong. So we need to help Python out a little bit and basically manipulate our data table so that each data type is the one that we want. So let's start with zip code. So first of all our values in zip code are being interpreted as integers. So let's convert those to a string. And here is what that syntax looks like. So what we're going to do is we're going to call our data frame here. And then we're seeing another set of square brackets here. In this case, the square brackets actually are defining a specific series. Remember, in pandas, the columns are called series. So it's defining a specific series or column from our data frame. Here, we're referring to the zip column. So you put the name of the column in quotes. All right. So this column here, I want to set this equal to something else. And what this is going to be is it's going to say, okay, take the value that you're getting from the zip code column, and I want you to convert that to a string. So essentially we're saying take that value, and then we're using this as type method right here. We're saying as type, and then that method has one parameter, and we're going to pass in string. So we're saying, okay, take your numeric value and convert it to a string is essentially what we're telling it to do here. And we're doing this kind of all in place. So the existing values of zip code column are going to be replaced with strings. So let's run that. And then now let's take a look at our dtypes property again. Okay, so now we can see that for the zip code column, Python is now recognizing that as a string data type. So awesome. We have accomplished the very first goal in our list of goals. And it was pretty easy. It only took one little line of code. Okay, now let's look at this income column. All right, so we know we want to eventually do some kind of numeric analysis on income here. So we do need all of our values to be valid numbers. So the first thing I'm going to do is I'm just going to go through and I'm going to say, okay, let me see all of the unique values for income in our data frame. And so I'm doing this by using a for loop. All right, so this syntax, it starts off with the word for. And so it's saying for something in something else, I want you to do this thing. I want you to take this action. And so in this case, what we're saying is we're saying for each record, so our V here is going to represent each record in our data frame. I want you to loop through all those. I want you to loop through all of the values in the income column, but not just all the values. I actually want you to go through and I want you to find all of the unique values in the income column. So let's break this down a little bit more. So our data frame is called data, and then we're using our square brackets and the word income in quotes to specify the income column. And then we're using this method right here, the unique method, dot unique open close parens, to find all of the unique values. So it's going to go through, find all of those unique values, loop through each one of them, and as it loops through it, it is going to just print it out to our screen. So the question in the room was, we have 168 or we have 1068 records, but our list of unique values is only like say 100 or so. And so that means that we do have repeated values in there. So in our 1068 records, we could see the value of 240 several times. Okay, so if we have a value of 240, we don't need to know that that appears 5 times right now. We just want to know, okay, that is one of the values in the unique list. And so that's why this unique really comes in handy, because I don't have to loop, or I don't have to search through all of my 1068 records. I can just say, okay, give me the unique ones, and then I'll just look through those real quick. All right, so excellent question. Thank you for that. Let's go ahead and run this and let's just see what happens. Okay, so we have a huge list now. It's not 1,000 different records, but it's a lot. And if I try to scroll through them, it's going to take me a very long time. But really what I want to do here, and I'm just going to scroll through a little bit because I want to find the offending value that is causing Python to not really understand anything that I'm trying to do here. So just be patient with me as I scroll. Okay, here we go. So in my list of unique values, I see that I have at least one record that has an income value of St. Louis. All right. Now, besides being a really good plug for data validation here, because obviously if you're asking someone about income, you don't want them to be able to type St. Louis in there, especially if they're not paying attention or whatever. So in my survey form, I might say, okay, this has to be a numeric value, or maybe give them a little number slider, or just some way to force your participants to give me the information that I actually need and not make any mistakes. But I didn't do that in my survey. So now I have a value of St. Louis for income, and it's causing me all kinds of problems. Okay. All right. So now that we know kind of what our issue is here, and if I looked through here also, we also have, I believe, some values of the word none too, which are probably also causing issues. But I'm not going to worry about that. Right now, I'm just going to try to say, okay, I know I've got some text values in here and I need to deal with them somehow. All right, I'm going to right click and I'm going to say clear output here because I don't need that whole long list to just stay in my notebook. All right. So we just found the value of St. Louis is invalid. And then we also had some values of none, which technically is an okay value. It's fine to have no data, but we don't want the word none. We just want null. Okay. So let's do the same thing we did before, and let's use this as type method, only this time let's say, okay, take all these income values, and now I want you to convert them to integers. So it's gonna go through and it's gonna be like, oh, okay, this is a number that I can convert to an integer, and it's gonna go ahead and do that. So let's see what happens. Okay, well, we have arrived at our first error. So this is what errors look like when you get them in your Python notebook. And a couple of key pieces of information we want to look at in this error. First of all, in this first section here, it's going to tell us which line of code is throwing that error. And since there's only one line of code in this cell, it's obviously that one. And then it gives you a bunch of information, like it goes through like the deep Python scripts that are stored on your machine that feed Python, and it kind of tells you where that error is originating from. I tend to just kind of ignore all this. And really what I'm interested in here is this very last line here. What is going on with this error? Like, why can't you proceed with what I told you to do? And basically what it's saying is it cannot convert the float nan to an integer. Okay, so my as type integer method is not really going to work. I need to find something else to get the job done here. So let's try a different tack. And in this case, we're going to go up to the functions associated with pandas now. Okay, so I'm going to do the same thing. I'm going to say, okay, take my income column and I want you to convert it to numeric. So this is a function associated with the pandas library. So pd.toNumeric. And then I'm going to pass in one parameter that says, okay, what do I want you to convert to numeric? I want you to convert the values coming in from my income column. All right, so let's try that and let's see if that works. Okay, so again, I get another error. All right, and it's saying that it's giving me this error right here. Basically, the gist is it can't convert the string St. Louis to numeric. So for the folks on Zoom, we're just having a discussion as to why some errors would occur with some functions and other errors would not occur with some functions. Like, why are certain values throwing certain errors? And so basically, I don't have like a one size fits all answer for this, besides that it is to just stress the importance of really interrogating your data like this to make sure that all of the values are what you think they are. And again, I'm going to say that this particular data set, it's just about 1,000 records. So theoretically, it's not too bad to just like kind of scroll through all of them. But imagine that we were doing this on a data set with like 25 million records. There's no way that we would be able to look at all of them. And so we need to kind of use these methods to kind of parse out the issues with our data. But this is a really good discussion. I'm glad that you are bringing this up. So the point here is that our two numeric function right here, it didn't mind the nans, right? But what it did mind was the value for St. Louis. And also, I guess at this point, I probably should note that nan means not a number. It's really like a stand-in for a null value. That's what nan means, if you see that. Okay, so it's not liking our St. Louis. Okay, so we need to try something else here. We're going to continue on with our two numeric function here, but what we're going to do is we're going to add an additional parameter. Okay, so here in this cell, again, we're going to say, okay, we're replacing the values in our income column. We're using the pandas two numeric function, and the first parameter is going to be the values coming in from the income column. Here is the second parameter that we've added. So comma, and then here's another parameter. So this is the errors parameter. We're saying errors equals cohorts. So what we are saying here is we're saying, okay, go through all the values. If you find anything that doesn't work, then just strip the value and make it a null. Okay, because if it's not a number, I don't want it. It's not going to work for me anyways. So just get rid of it. I don't care. All right. All right, so let's run. Yay, it worked. No errors this time. Okay, so now let's take a look again at our list of unique values. So this is the exact same code that we ran up here to get our list of values here. Okay, so let's run this. So I'm not going to explain it again. I'm going to just run it. Now, immediately I see one thing is true. I see that it essentially has converted all these into numbers, and it has added like a .0. So essentially it's made it like a double numeric type. The other thing that I would see if I scrolled through a little bit, and let's see if I can do this without, again, wasting a ton of time. But really what I want to show here is that that nan value has showed up as not a number. So essentially it's taken all of the invalid values here and it has made them null, which is totally fine. Null is also a valid value. There it is. All right, nan. Okay, awesome. I'm going to right click and I'm going to, sorry, get this clear output. And then just as an additional way that we could kind of do this same thing, and this is a handy piece of syntax to know about too, is this is saying, okay, I want you to isolate, I want you to take my data frame and give me all of the records where the income value is null. And so in this case, we wouldn't say income equals null. There's actually kind of a built-in method is null, which says, give me everything that's null. And then you can also do the opposite if you want to find everything that's not null too. There's also an option for that. So here's what this syntax looks like. So we've got more square brackets here, all right? So again, we're going to kind of walk through the square brackets. Okay, so the first thing is data, which is the name of our data frame. Then we're saying we're going to filter this data frame. And so this first set of square brackets here and here is the pandas syntax for filtering a data set. So we're saying, okay, I want you to filter my data frame. And then here's all the records that I want you to pull out. I want you to pull out all the records where data, income, so the income column. So these second square brackets are indicating the column that I want. And then I'm saying, okay, give me everything where the is null property is true here. Or sorry, that's not a property. It's saying, this is a method saying find all the nulls. I know it's a method again because it has parentheses attached to it. So everything that's null in my data frame, I want you to print that out for me. So I do that. And so it gives me just these handful of records here where somehow it did not like the income value. Either it was already null or set to none, or maybe it was the value of St. Louis, and it just made those null. So we just have a handful of records here where that happened. Okay, good. So we have now completed item 2 of our list. All of our income values are numeric, and we've gotten rid of all of the invalid values. We're going to go on to the next super fun part, which is looking at consistent values. Okay. So next up, for our analysis, we're actually going to be aggregating these values by what city they're in. So we need to make sure that all of our values here are consistent. All right. Thank you. And so what I mean here is, we are here in the city of St. Louis. And if you've ever looked at any kind of data for the city of St. Louis, there's about 253 different ways of referring to the city of St. Louis. So we've got Saint space Louis, like Saint written out. We've got Saint period Louis. We've got ST Louis. We've got STL. So tons of different ways of referring to the city of St. Louis. For our analysis, we need to make sure that all of those are the same. So we're going to run our unique method again, and we're going to run it on the city column. And in this cell, I'm showing you another way of how you can access a specific column in your data set. So instead of doing these square brackets and name of the series in quotes, you can also do this: name of the data frame, dot, name of the column, dot, and then this is pulling the unique values. So this is going to the city series and using the unique method to pull all of those unique values. All right, so let's run this. And so it's returning essentially a list here with these values. So it went through all 1,000 plus records, and here's what we got. We've got ST space Louis. We've got Saint space Louis, Saint written out. We've got Kirkwood. We've got U City. We've got Saint ST period space Louis. And we also have University City. And then we also have Mo. So somebody input Mo for their city. All right, so that's not correct. So we're going to need to fix that too. Also, I'm seeing the few different spellings of St. Louis and 2 different spellings of U City or University City. Okay, so let's look at University City first. Now, so far, what we've been doing is we've been kind of updating our data values for each city in place, each series in place. I want to just show you how you can actually create an entirely new column in your data frame if you want. So just by way of example, in our data frame, we're going to create a new column called country, and we're just going to populate every single record with the value of USA for the country. So this is just a little example. So I'm going to run this. And so once I run this, Python says, oh, you're calling the country column. I'm not seeing a country column in the data frame already, so that must mean that you want to create a new one. So it creates a new one, and it gives all of the records the value of USA. So if I check on that by using my head method here, so just the first 5 records, I can see that it has created this new column for me here, country, and that it's populated all the values with USA. Okay, so now let's look at how we can create a new column with our corrected city name. And so in this case, what we're going to do is we're going to use that replace method that we looked at before we got into the code here. And so we're going to input 2 parameters. We're going to input the string that we want to replace and then the replacement string that we want to replace with. So let's take a look at this syntax. So first of all, I have the name of my data frame, and then in square brackets, I have city corrected in quotes. So that basically means I want you to create a new column called city corrected. What do I want to put into that column? Well, we're going to take the value from city, and then we're going to do the replace method on it. What I want you to do, Python, is I want you to look for all of the instances of U space city, and then I want you to replace them with the full word written out university city. Okay. So looking for U city, replacing with university city. All right. Simple enough. Let's run that. Now let's take a look at our new column that we created, city corrected, and let's look at all of the values that came through there. Okay, so again, we're still getting a list, all right? And our operation did not touch any of the St. Louis values because we didn't give it any instructions about St. Louis, but it did go ahead and it found all those values that were U City and it changed them to University City because we, in our unique list, we're not seeing U City here anymore. So that's great. So we're getting there, all right? All right. So we can also look at the values another way if we want. So I can create a new data frame and I can say, okay, subset all the records where city equals U city, and also give me the records where city equals university city. So here's what this means. We're creating a new variable called U city, and to create that variable, we are taking our data frame and then we're running a filter. So here is my filtering brackets right here. What I want you to filter out is all the records that meet this criteria. Either the city column equals U city or the city column equals university city. So let's parse this a smidge more. Now notice how I'm using two equal signs here to say where city column equals U city. So in Python code, we use equal signs a couple of different ways, just like we use square brackets a couple of different ways. When we're using a single equal sign, this is an assignment statement. So this is saying, I want you to take this variable and assign it the value of this. When we are testing for equivalency, we signal Python that we want to do equivalency test by using two equal signs. So we're saying, okay, give me everything where city equals U city. And then this pipe operator here means or. So give me everything where city equals U city or city equals university city. So that's going to create a whole new data frame. And then it's just I'm just going to run that head method just to see the first 5 records or so. Okay. So now I can see that there are some records that had U City and some records that had University City. And now they all have city corrected in their, they all have University City in their city corrected column. All right. We also noticed that we had the value of Mo for a city. So let's filter those records out and look and see what's going on there. So I'm going to use the same general type of syntax here. We're filtering out everything where city equals Mo. And let's run that. And so one record is returned. And basically it looks like whomever was inputting this data input city as Mo and then also state as Mo. All right, so we know that's not correct. Now we can kind of do a little bit of inference here. So we can see that this person does live in this zip code. So probably it was just a mistake. And what we're going to do is we're going to insert the value of St. Louis into this record. So next up, what we're going to do is we're going to use that replace method again, and we're going to do it right on the city column as we just discussed, and we're going to replace any values of Mo with St. Louis. We validated this because the zip code is in St. Louis, so we're going to assume this is also St. Louis. All right, so we're going to run that. And now we can take a look at this specific record again. We're going to use the case number in this case to isolate this record. And so we're going to say, okay, give me all the records where case number equals 1059. And now we can confirm that the city has been corrected to St. Louis. Discussing, when we were tackling U City, we added a separate column. But in this next line here, I just wanted to show that we could basically do that same thing in place with the city column. replacing U city with university city. So essentially we're altering city column now to fix that. So if we look at all of our unique values again, it looks like university city has been taken care of, and our Mo is gone now. That's great. And so now we just need to deal with our different versions of St. Louis. Now, we've got these three different versions of the phrase St. Louis. We could theoretically use the same replace function to alter those as well. That is certainly an option. But here, my whole point is to show you different things, right? Because we're learning about Python syntax. And so what I'm going to do here is I'm going to introduce the concept of regular expressions. Anybody heard of regular expressions before? No? Okay. If you're still with me, give me a thumbs up if you've heard of regular expressions. But basically what regular expressions are just a really robust way of finding patterns in strings. Some people refer to them as wildcards on steroids. So instead of just finding like one string that we're looking for, we want to find lots of different possibilities of strings. And then we want to do something to those records. Okay. Now, regular expressions, or also referred to as regex, is a built-in module within Python. So if we want to use it, we don't have to import it, or excuse me, we don't have to install it. It's already there, but we do have to import it. And I would say that regular expressions is not just limited to Python. You can use regular expressions in many different programming languages, as well as some text editors and things like that. So it's kind of its own programming language onto itself. And I did give you a link here if you're interested in learning a little bit more about it. But for the purposes of our workshop here, first we need to actually import the regex module into our script. So I'm going to just run that import space RE. And so the next thing is we need to tell Python the pattern that it wants to find. So if I look at all my values of St. Louis here, one thing that they all have in common is that they all have something and then the word Louis written out. And so I can latch on to that and I can use that to find basically any strings that have something, something, and then Louis. Now, this might not work for every data set. Like, say you have cities of both St. Louis and then, I don't know, another word that is something Louis, city of Louis or something. I don't know. So obviously that would cause us some issues for this strategy. But for now, this is going to be okay. And so what I want to show you next, I'm going to go back to my presentation and I'm going to show you how we can codify this pattern for Python. Okay. So here's basically what we mean. So regex is going to be a series of characters that mean something. And so we're starting with the string Louis. Okay, so first and foremost, I want you to find everything that it has Louis in it. And then I want you to do a couple of things. First of all, I want you to find anything that's at the very beginning of the string. That's what this little caret means. And then the parentheses are saying, find me anything that fits this criteria that's at the beginning of a string. And here's the criteria that I mean. I mean actually any character, that's what the period means. And the asterisk question mark means any number of instances of the previous character. So that means any number of instances of any character at the beginning of a string. And that means that it's going to qualify to be St. Louis for me. All right. So that's a super quick look at what the pattern actually is. And again, if you think regular expressions are would be useful to you, where's my workbook? There we go. Then please do check out regex 101 or the Python W3 schools page, because regex is a really powerful way of finding complex patterns in your text. So basically what I'm going to do is I'm going to set a variable to STL pattern. And this is going to be a regex object. So I'm going to use a regex method to create it. So I'm going to say, okay, in regex, I want you to compile, and then here is the pattern. So this is the same pattern that I just showed you on the slide. It's just in my code here. So this is the pattern that I want you to find, Python. All right, so I'm going to run that. And just for kicks, what is this object type? Like, what does Python think it is here? And again, this is a pattern. It's of the pattern class within the regex module. And so now I can use our replace function, which we're already well versed in by this time. And I can say, okay, instead of finding just like a regular string that I'm going to pass in, I want you to find this regex pattern. So let's take a look at that syntax. So we've got my data and my city column. So this is essentially saying within our city column, I'm going to replace these values. And I want you to look in the city column and replace the following. What do I want you to replace? I want you to find all instances of my STL pattern that I created here. What do I want you to replace it with? I want you to replace it with the value of ST space Lewis, or sorry, ST period space Lewis. That's what me and my research team, we've decided that we're going to call St. Louis ST period space Lewis. So that's what we're going to use. And then there's a parameter that I've added here, which is regex equals true. So that basically tells Python that when I'm running this code, this replace function, I want you to use regex here and recognize my regex pattern as a regex pattern, not a plain string. All right, so let's run this and let's see how we did by calling the unique function. Yay, we did it. Okay, now if we look at all of the unique values for city, we've got 3 very clean values here. We've got St. Louis, we've got Kirkwood, and we have University City. Awesome. All right, so this shows us that there's a lot of different ways that we can experiment and manipulate strings within our data frames. Let's go ahead and do the final component of what I would like to get through with today's workshop, and that is looking at joins. All right, so it is really common that our data is probably going to come from a lot of different sources, and we probably want to, instead of working with each table separately, we might want to join them and make like one big table of all of our records. Okay. And so to do that, what we do is something called a join, which is essentially taking 2 tables, finding a similar identifier in each table, and then joining the records based on that identifier. So the first thing we're going to do is we're going to bring in our second file, and we're going to do this using the Google Drive link that we talked about before. But we can't just use that straight up Google link. We actually need to manipulate it just a little bit so that we can directly bring that data table into Python. All right, so just as a reminder, our data file name is this string that I just pulled right from Google Drive sharing. And what we're going to do is we're going to split that string. And so essentially what that means is we're going to take a string, we're going to tell Python, okay, split my string at this particular character and output a list of all of the chunks of the string that were split. So here's what I mean by that. I'm creating a new variable called URL split. And to do that, I'm going to run the split method on my data file named to variable here, which is this. And so the split method only wants one parameter, at least to start. And what it wants to know is what character should I split this string at? And so I'm saying, okay, Python, I want you to split this string at the /. And so after I do that split, I'm going to print out URL split results so we know what we're looking at here. So let's run that. Okay. So I can see here that we've got, here's one chunk that came from here. Then we've got essentially like a blank that came from right in the middle. Then we've got drive.google.com, which comes from here, and file, which came from here, and so on and so forth. All right, so here's another square bracket. And this square bracket in this case is signifying a list. Okay, so I'm not interested really in anything with these values, with the exception of this string right here. What this string right here is the unique identifier of this item on Google Drive. Bless you. So what we want to do is we want to take this value and then we want to stick it into the direct URL, the download URL of this item on Google Drive. And then that will allow us to bring the table into our Python notebook. So we're starting off with creating a new variable called URL. And we're going to stick in front of it the URL that is the starting URL for all Google Drive direct download links. And then to that string, we're going to add the second to last element of our URL split list. Now here we're seeing another set of square brackets that mean yet a different thing. So what these square brackets mean are the index for the element we want to pull from this list. So all the lists have indexes. So this is the 0 element, the 1 element, the 2 element, the 3 element, and so on and so forth. If we say, pull the -2 element, this means go to the back and then go up 2, and that's the element that I want you to pull. So we're going to pull that ID, we're going to add it onto a URL, and then let's see what that looks like. So that creates a URL, and you don't need to do this with me, but just by way of showing you, if I click on that URL, it's going to start downloading this file automatically, okay? And that's what I want. I'm not actually going to be downloading this file in the same way we did with the other files. I'm going to be pulling this file in directly. So now what we can do, going back to our read CSV function that we did right at the beginning of our workshop, I can pass the URL into the read CSV function, and Python is going to go out to Google Drive. It's going to retrieve that CSV and it's going to bring it into the script. So let's look and see what that looks like. Okay. So it read it, and then I just printed out just the whole data frame. And basically, we're seeing a data frame that has these columns and these records. And at the bottom here, it looks like we only have 29 records. Okay, so not a huge data frame. I'm going to clear that output out. And so if you recall back when we were talking about our goals, we want to join this table to our original table using zip code. And so that means that we need not only identical values in both of our zip code columns, but we also need them to be of the same data type. So the data frame we're talking about now is called demographic data. And so I'm going to look at the zip code only column and just look at only the values in that column. So to do that, I'm just calling this series here, the name of the data frame, and then the name of the series in quotes. All right, so this is only the zip code column. All right, and then I also see down here at the bottom that Python also recognized this as an integer, okay, which we already know how to deal with. So what we're going to do here is we're going to create a new column in our demographic data frame, because recall that our original column was named zip_code. Now we're just going to create a new column called zip. And here is what I want you to put into this column. I want you to take the value from the zip code column, and I want you to convert it to a string. So let's run that. Again, our as type method worked fine here. And then if I get our dtypes property, I can see that zip is a string Python. All right, so now all the stars have aligned. We have everything kind of ready to do our merge or our join, but we kind of need to know what join we want to do. And so for this, what I'm going to do is I'm going to flip back to my presentation. And I'm just going to give you a really brief refresher maybe on how to do joins, or what we're talking about when we talk about joins. Okay. So imagine we have two tables here. Table A is a list of authors, first and last name, publisher category, and they have an ID number. And then table B is a table of books, the title of the book, the price, and then the ID that represents the author. So note that we've got this ID column here that is going to be the key we're going to join our two tables on. All right. Now, I always like to do a refresher on this because I never remember, like, what are you talking about? Which left join, which right join? What does that even mean? Okay. So this is just a really easy way to remember. So a left join is all of the records on table A and only the records from table B that match the records in table A. A right join, alternatively, is just the opposite. It's all the records in table B and only the records from table A that match. An inner join is only the records from table A and table B that match. And a full outer join is all records, no matter if they match or not. Now, depending on what you're doing in your research, there might be cases where you're going to need to use all of these or just some of them or whatever. And here's what these might look like. So first of all, from our left join, all the records from table A and only the records from table B that match based on the ID field. So we can see that the first three records matched, but then this particular author did not have a record in the book title table. So we are seeing null values there. On the flip side, let's look at the right join. So here is the complete table from table B, all of our book titles, but we can see that this author with this ID did not appear in our authors table. So we're seeing null records there for that particular book. For our inner join, only these three records matched in both table A and table B. And so that's what we're seeing here for our inner join result. And then for our full outer join, we're seeing all the records from table A and table B. And then of course there's nulls where the records from either table did not retrieve a match. Okay, so there is your little like refresher on joins. All right, going back to our workbook here. All right, so we're gonna merge these two tables. We're gonna merge them on zip code. And when I say merge, I actually mean join, like those can be used interchangeably because the join function in pandas is actually called merge. And so the merge function wants two important parameters. They want to know on, so what is the identifier that we're going to join these tables on? And then two, how are we going to join them? Is it going to be a right join, a left join, a full inner join? What do you want? Okay, so what I'm going to do is I'm going to do a left join because I want to keep all of my records from my first table, which is my survey results. And then I'm going to bring in only the records from my second table that match by zip code. So I'm going to create a new variable here. It's going to be a new data frame called data with demographic. And I'm going to use the merge function within pandas. So pd.merge. And then here's what these three parameters are here. So table A is going to be my table called data. Table B is going to be my table called demographic data. For the on parameter, what do I want you to match these records on? And that's going to be the zip code column. And then how do I want you to join them? I want you to use a left join. So that's my syntax for doing the join. And then I'm just going to show the data with demographic table when I'm done. Yes. So the question is, what does the left mean? Like, what does that mean, right? So the how equals left means that we're doing a left join, which means we're going to take the output is going to have all of our records from the left table, which is table data. That's the first parameter here. The right table is demographic data. And so a left join means keep all the records from the left table and only the matching records from the right table. And that's what I'm specifying here, how equals left. So if we look at the output here, and it's kind of truncated, it's given us the first 5 rows and then the last 5 rows. we can see that, yes, we have all 1,068 records from our left table or our first table that we were working with. But then we can see that here's the columns from our second table, and only a small percentage of those have joined because their zip codes actually matched. So we can see in this top record that we did not have a zip code that matched the zip code of this record. So we got null values for those records, for those columns. This second column, or excuse me, this second record did match. And so we had values from our second table that came in there. So that's why we're seeing a bunch of nulls here, because it didn't have corresponding zip codes in our right table or our second table. Okay. All right. So so far so good. Our join worked successfully. But we do have a lot of nulls here. And let's take this in context of our project. Say we don't really care about any of the records that didn't match. We only want to output the records that did match after our join. So let's isolate those records. I'm going to create a new data frame called join matches. And to do that, I'm basically going to filter out my data with demographic data frame. So I'm going to filter out this data frame. And then what am I going to filter out? I'm going to say, okay, give me all of the data from my data with demographic data frame where the zip code is not NA. So that means anything that doesn't have a null value, that's what I want you to keep. And specifically, doesn't have a null value for zip code. Because if the record doesn't have a null value for zip code here, then that means it did find a match. And so those are the ones that I want to keep. And then I'm going to just print out my table here. Okay, so now I have my join matches table, quite a few records here in it, but just by doing a quick scroll, I can see that none of those null records came through. So that's great. Okay, now finally, I've done all this work. I've done my join and everything. Now I'm going to export this because I want to use my table in some other application. All right. Say I'm going to put it into Tableau and make like a visualization, or I'm going to, I don't know, just send someone a CSV file. So let's write my output to file. So the first thing I'm going to do is I'm going to create a variable that's going to be the name of my output file. And I'm just going to call this survey joined to demographic data, just to give it a descriptive file name. And then it's really easy. I'm going to do the toCSV method associated with the data frame object. And I'm going to say, okay, export this join matches data frame to a file with my output file name. So let's run that. Now, if I look over here at my files list, and maybe do a little refresh, I can see that I now have a new CSV called survey joined to demographic data. Great. If I wanted to preview this, I could click on the CSV, double click, and it gives me a little preview of that CSV here on the right-hand side of my screen. Now, so far, so good. This is looking good, but there's a couple of things that I notice here. First of all, I still have my index column here, which I don't really need if I'm going to be taking this out of Python. So let's get rid of that index column. And I'm going to close that, close tab. So to do that, what I'm going to do is I'm going to do the exact same code I did before, but I'm going to add a new parameter. I'm going to say index equals false. So that means do not include the index in my output. So let's run that. I'm going to do a refresh on my files list, and then I'm going to double click on my CSV, and sure enough, my index field has gone away. Okay, awesome. Another thing I'm noticing, and as we discussed before, is that I added that new column of city corrected when we were doing our data validation on the cities. And I don't really need the city corrected column anymore because I already ported those values back to my city column. And so this is just really going to get in the way. So let's close this. And so this is just a little demonstration of how you can specify the columns that you want your export to have. So the first thing I'm going to do is I'm going to create a variable called call list or column list. And all I'm doing here is I'm saying, okay, go to my join matches data frame and get all of the columns. So this is the name of the data frame dot columns is how you can access the names of the columns in your data frame. And then I'm using this list method here to convert all the column names into a list. And then I'm going to print that. Okay. Then next, I'm going to say, okay, for my column list, I'm going to use this remove method now. And what do I want to remove from my column list? I want to remove the element that is city corrected. And after I remove that, then I want you to print out the column list again. So let's run that and let's see what happens. Okay. So the first list that printed out, we can see that we are seeing the city corrected column in there. And then the second time we printed it out, the city corrected column is gone. So this is awesome. So this is getting rid of that city corrected column, and my output data frame or my output CSV is going to be nice and clean with just those columns that I want. So we're going to use our toCSV function again, same parameters as before, to our output file and index equals false. But next, we're going to add a third parameter saying that the columns I want you to export are the columns in my column list here. And since my column list has been updated to not include city corrected, that means that city corrected is not going to be in my output. So let's run that. Let's run a refresher, just the refresh button on my files, and let me double click that to preview. And I can see here that my city column or my city corrected column is not included. So we are all set now to take this CSV. We can pass it back to our research team. We can bring it into some application, and we'll be ready to actually do some additional analysis on these values. Okay. Now, I want to just let you know that after this section here, if I just go back to the navigation, I've included several kind of bonus content sections, all right? Because like I said, you'll have this Python notebook. You can go back and refer to it or whatever. But there's some other things that I find that researchers come across a lot that we didn't have time to cover in just 2 hours, but I feel like they might be useful. So I've included just some additional information and syntax for that. So one is if you want to read multiple input CSVs into a single data frame. Another is adding leading zeros to a string, like we were talking about the zip codes there. Some additional work on splitting up values. Everybody's favorite, working with dates and times. And then finally, reshaping tables. So if you have a table with a lot of columns that is very wide and you want to, reformat to be a very tall table, there's a module on how you can do that. Also, if you want to access content not from like a public Google Drive, but if you have your own Google Drive with files saved, there's a section on how you can access those files too. So please do take a look at those and feel free to let me know if you have any questions or if there's any other things that you're wanting to do in Python. I'd be happy to help you walk through them. So I just want to thank you for sticking with me for these 2 hours, going through kind of the nitty gritty Python syntax stuff. Again, I know that you could probably ask AI to do some of this stuff for you, but like I said, we do need to make sure that we know what our Python code is actually doing. And this is just one step in actually achieving that goal. So thanks again. I'm going to just put up the library's website there in case you want to reach out to either myself or if you're looking for any library resources, I'm happy to point you in the right direction. And if you're doing any work with GIS, feel free to reach out. But for now, I'll just say thank you and hope to see you again at another workshop, either mine or maybe some of the other data lab workshops that are being offered here at the library. So thank you so much.